Hello friends. So in this video we are going to see how to invoke and call lambda expressions in our code, and we will also see how to use lambda for polymorphic situations, for polymorphic uses, and we are very much aware uh, how we implement polymorphic scenarios in our code. So let's say uh, see it by one example. So let's say we have our one main program and we have our coach interface which have abstract method that is coach type. So the main purpose of interfaces, why we use interfaces in our code, you guys are very much clear about this uh, agenda. So we use it uh, somewhere like in a situation where we have n number of classes and those n number of classes want to implement this course type as per their will. So we will see it here. Let's say in our program class, this is our main class having main method. um, there are two classes. Let's say class AA implements coach interface. Okay, so here it is showing error because we have not implemented the abstract method coach type. So we need to implement it here. Just to add an implemented method, remove this part, and let's say this coach type want to have cricket coach. This is a big fan of cricket. So here this class want to boost the cricket skills, cricket coach. Okay, so here we have one another class. Let's say B. uh, this class also want to use coach type method, and this class want table tennis coach. Okay, so inside our main method, what we need to do it in this scenario, we need to create object of a class, and on this object we will call the method. And same scenario we need to do for B class. So here we are achieving polymorphism in a way like both the classes implementing the method declared inside the interface as per their will. So just run the program and check the output. We are getting cricket coach and then table tennis coach. So uh, by this we are able to achieve it. But now my point is here, as we are discussing, we can use lambda for polymorphic uses also. So now I want to use lambda expressions here. Let's say coach interface, and we can create references of interface, but we cannot instantiate it. So for handling lambda expressions, references are pretty fine enough. So we will create one reference. Let's say lambda 1. Okay, here we already know how to write lambda expressions. So here suppose another cricket coach we want to use. Let's say cricket coach 1, and what we need to do on this reference, we can on this reference we can call the declared method. Let's say we want to add another table tennis coach also. What we need to do, just change it here. Instead of cricket coach, we are using table tennis coach. Now just run it and check the output. Here we are getting it. So now just look, we are achieving polymorphism by using lambda in pretty simple way. We do not need to write classes, and we do not need to write instantiate that and creating object. So we can avoid this part, because in this scenario the dot class file for AA class and dot class file uh, for BB class will be created by the compiler, but we can avoid this by doing so. So just do it, control shift forward slash and comment this part, and you can avoid all these two classes also. There is no need to write this too, and we are achieving the polymorphism here. Run as here we are getting. So in this way we can implement it. So now here we are using coach interface, moving like our second first point is clear. Now second point, for handling invoking lambda expressions, what we use. So looking, just look it, this is our lambda expressions, and we can say this is our lambda method, and for handling it we are using coach interfaces reference. So just do and check one thing, can we use all type of interfaces for handling? Now the question will come over in my mind, can we use all type of interfaces for handling lambda expressions? Just check it. So uh, try to declare one another method here. uh, let's say uh, let's say coach workout. Okay, the moment we will save this, it will throw an error. Just read it. The target type of this expression must be a functional interface, and the property of functional interface. So we are clear that what we need, what we will use, functional interface. And what is the property of functional interface? The property of functional interface is it will have SAM, that is single abstract method. So here suppose my coach interface, here we are having two. So the best practice is, suppose 20 20 in this scenario, suppose I have team of uh, 10 people, and one came and do the changes in this interfaces. So it is not throwing error here, but it will throw error in all the classes where we have used lambda expression for handling it. So the best practice is always, instead of doing this, wherever we have used functional interface, we should use this at the rate functional interface annotation. The moment we will do it, it will throw error while changing this, because it can only create one single abstract method. So it will not allow to do changes here. It will not allow to do changes here, then our error in classes will not appear. So this is the best practice we need to do. Wherever we have to declare functional interfaces, we should use this functional interface annotation.